You've already learned how to make stem plots and dot plots for small data sets, but when we get to larger data sets, it just doesn't seem very logical to utilize those graphical displays in that setting. So instead, we use one of the most popular graphs in statistics called a histogram. We're going to start by making a histogram using one of our examples from an earlier video. And then when we're done, we're going to talk about what makes the histogram what it is. How is it different from other graphs and so forth. We're going to bring back an example from when we did frequency distributions, which was the number of TVs per household problem. Our goal now is we're going to be creating something called a frequency histogram. Okay, so where do we get started? Well, first of all, you can see that in my table that I have here, that I brought back from an earlier slide or video, I actually have frequency and relative frequencies here. Since this is just a frequency histogram, then that means that we're not going to need this in order to accomplish our goal. Okay, the first thing you do when you make a frequency histogram is you make your axes like you would see on a graph. Now, normally this is the x and this is the y axis, but that does not need to be labeled in a frequency histogram, or really shouldn't be. But it is important to get, generally that's the concept that's going on when we make this graph. We want our graph to basically be in this quadrant of a typical axis or graph, so we're going to be there. The first we can then, we want to take the category or what makes our classes and our problem and put it on what normally is the x-axis. We then want to make a scale of our single value classes that we dealt with when we were creating frequency tables. Now, a small thing here that you want to be very careful of, since we do want our graph to be over here, the problem is on an xy axis, typically 0 is right at the intersection of the axes. The problem is what that's going to do is, in a histogram, we make bars. That is going to be a very ugly place to put a bar, and we're going to need to label that axis, so that's no good. Which means what we have to do is we're going to have to move our values over a bit, as such. When we do such a thing, we must add one little tiny bit to the picture that informs the reader that our graph is not to scale. Something is to scale when it's accurate, and when this would be typically accurate, as we spoke of, the 0 would be over here. Since it's not, we usually do like a little double backslash over here. Again, all it does is tells the reader of the graph that we have messed or altered the scale of a typical graph in order to make this work. Next, we want to talk about frequencies. So if we look at the frequencies that are possibilities here, it looks like our lowest frequency is a 1 and our largest is a 16, which means that we need to populate our y-axis with values that go up to 16. We could do that by counting by 2s, 4s, doesn't really matter. I think just for the purposes of this, to make it look nice, we'll go by 2s. So we got 2, 4, 6, 8, 10, 12. I'm going to see if this erases that. Nice. And then we go to 14, and then we're going to have to go a little higher up here, 16. Let me get my blue or purplish to hit that. All right. So our scale then is our frequencies, which we want to label over here. Frequency. And we have basically everything labeled for what we're dealing with. Now, often, I'm going to erase this up here for now. We usually put a title to our entire graph. And if you want to, it's kind of repetitive often to the x-axis, but if you want to say TVs per household. Okay, so finally we've gotten to the point where we need to make the physical histogram. And before we get started with that, I want to talk about the bar chart. So when we want to graph qualitative data, non-numeric, we can use something called the bar chart. So a bar chart looks something like this in a nutshell. You're going to see that in a bar chart, there's spacing right here between the bars, and normally we're doing qualitative data like A, B, C, D, or category of some kind, right? So in a histogram, what ends up happening is the bars are going to blend together, and at the bottom, you're going to end up with numbers that you're dealing with of some kind. You're going to be dealing with, in a nutshell, quantitative data. So again, bar charts, which are up here, qualitative data, space between the bars. Histograms is quantitative data, no space between the bars. All right, so in a nutshell, what do? Well, we go over to our table over here and we say, all right, we got 0 TVs, that happens once. So we go over to our 0, which is right here, our 0, and we want to draw a bar that actually straddles the 0 that goes up one spot. So if you go over to the scale over here, 1 would be about right there. So we're going up one spot. Then we go over to people who owned 1 TV. There were 16. So this is going to shoot up all the way to the top. So usually I just take the line from the previous one. We go up to the top, and then we come down in the middle between 1 and 2 exactly. We do the same thing for all the rest of the numbers. For 2, we have the number 14. For 3, we have 12. For 4, we have 3. For 5 and 6, we have 2. Okay. Messed that up a little bit. Okay. So this, in a nutshell, is your histogram. So the histogram creates bars. The heights of the bars represent the frequency in which that class is coming to fruition. For example, 6 TVs has a height of 2 because that occurred 2 times. Your goal in the end is that you're going to need to be able to not only draw a histogram, but you're going to have to be able to interpret one. So you have to be able to come up with this, but also look at this graph and answer questions using it, like what frequency of the time did the person have 3 TVs? So you would go to 3, you would go up to the height of 3 and look over and go, oh, 12 people answered 3. Okay, so one of the key ideas from our tables that we work with was the difference between frequency and relative frequency. So we talked about how a frequency was a count and a relative frequency was basically a proportion or a percentage divided by 100 with the decimal place moved. So the same thing has to go for histograms. So we've talked about I erased it unfortunately, but this was a frequency histogram. Okay. So you could also be asked to make a relative frequency histogram. Now, relative frequency histogram is similar, but there are various things that could be a little bit different with the graph that could happen between the histograms or any histogram, so we'll talk about that as we go. First things first, this was ages at a bingo hall, so let's throw that as the title. Oops. It's not bingo, it's bingo. Ages at a bingo hall. And we know that we have to create X and Y axes. But something's different. So if you notice, first of all, we don't need frequencies. It's a relative frequency histogram. So we're going to need just our values here. So that's going to be a little different. But if you look over here, we have grouped classes. So you remember we made these in a previous video. So with grouped classes, that's going to change the dynamic of our x-axis just a bit. What it doesn't do, obviously, is we still know we have to write age on this axis and relative frequency on this one. We start with the scale on the bottom, a little bit different, right? So single value classes, we just had to write the numbers 0 through 6. Here, we have groups of things. So what do we need to be able to cover? Basically, all the numbers past 99 and all the numbers starting at 30. So it makes sense that we can start at the number 30. Now, there's two ways to do that. So we could, for example, just span it out like we normally would. So this is normally 0. So this would be 10, this would be 20, 30, 40, 50, and we have to go to 100. Okay, that would be perfectly fine. There's no problem with that. But hypothetically, I'm going to write alt for alternative over here. We could take that axis and do something a little bit different. For example, we could start at the number 30 right here and just go 30, 40, 50, and so forth. Till we get to 100. Now, if we do that, we have to be careful. We can't just leave it like that. Why? Because this distance here is 10 and this distance here is 30. That is not drawn to scale. So if it is not drawn to scale, that means we always have to, again, put that double backslash. So we have two options. We could here start from 0 and just go through the scale. It's not too bad because we'd be starting the graph around here somewhere as our first value. If we don't want to waste the space in here from 0 to 30, then we could start here and then just make sure we have the double backslash. Either option is fine. I would say in most circumstances, if you were a statistician doing this, then you would probably do it this way because you don't ever want to waste space, but it really doesn't matter. I'm going to do it the other way because I want to show you what a graph would look like without a double backslash needed in order to do it. All right, so x-axis taken care of. Y-axis, we need relative frequencies. So this can be a little tricky for students. So we need these numbers here, and they're decimals. So what I say to students is you just want to think of them if they weren't decimals. For example, if you're looking at this number here, what is this number? Well, this is technically 10%. This is 17.5. 17.5, 25, 20, 2.5, 7.5. Think of them as percents, and usually your brain has a better handle of it. For whatever reasons, the decimals, when they are two decimals to the left for proportion speak, it can be a little challenging. So, what do we need to go to? The highest number is 0.25 or 25%. So my thought is, why don't we go from, fives in a nutshell until we get to 0.25. So what does that look like? That would be 0.05, 0.10, 0.15, 0.20, 0.25. So again, now we just have to make the bars. So our first category is from 30 to 39. So if we're going from 30 to 39 and we still need the bars to stick together, that means we need to edit our bar a little bit. So last time, if you remember, the bars actually straddled the number. That's not going to make sense for this, because if we're going from 30 to 39, they should span the numbers from here to here. And that's exactly what we're going to do. So 0.075 is actually right here on the graph. So we are going to go from 30 and we're going to actually end at 40. Now, students sometimes look at that and they're a little bit, they don't like that because it makes it imply that it's 30 to 40. But what usually happens is we tend to, it's kind of a given that the final number is not actually included in a histogram. It's kind of a known thing. So when you look at a histogram, you always assume when it spans numbers that it starts at this number but is not going to include the number that's at the end. And that's pretty much how we go by it. So if we continue on, 40 to 49 is 0.025, so that actually looks like that's going to go lower. That's here. So we're gonna go right here from 40 to 50, which is gonna be our 40 to 49. From 50 to 59 is gonna be 0.2, which we're gonna shoot up to here. From 60 to 69 is 0.250, which is our highest value. From 70 to 79 is 0.175, which is in here. So we can go right off this bar here and down. We have 2.175, so 80 to 90 is the same thing. And then we go down a little bit from 90 to 99 to go to 0.1. This, in a nutshell, is our relative frequency histogram. So the bars touch. They actually show real spans of numbers when you look at them, and they have relative frequencies on the y-axis. So in the end, histograms are the most popular graph in statistics. You will see them a lot, basically. You have to be able to distinguish between a frequency and relative frequency histogram, just like you had to do the same for tables. It is wise to understand that a histogram has the bars touching, as opposed to not touching in a bar chart, and the difference between the quantitative and qualitative nature of the data and the two graphs. These are the main things. It is possible you will have to make a histogram on your exam.